Okay. Assalamu alaikum warahmatullahi wabarakatuh. My name is Daanyaal Matthews, and this is, of course, the voice of the Cape Matric Revision Program. Of course, Matric finals are coming up, and we all know it's a very, very stressful time. So preparation is crucial, and it's not only helping you in remembering facts, figures, topics, and methodologies, but also it helps you know in confidence and avoid anxiety that plagues so many matric students. This episode is, of course, with Muntasir Kadri. He is a BSc Chemistry and private tutor at Intune, and today's topic is Maths Paper 1. Assalamu alaikum, Muntasir.
Walaikum salam wa rahmatullahi wa barakatuh. Thank you for having me.
No problem. How are you doing today?
I'm fine, alhamdulillah. Can't complain. Just looking forward to this session.
I'm not. I'm not. I'm terrible at. Yeah, this was the subject. I just got 50% in, and I went on with my life. But with that being said, I will have now Muntasir continuing with the program. So Muntasir, take us away.
Okay, shukran. Okay, so today we'll be doing Maths Paper 1. We'll specifically be looking at question 1 of the exam papers. And this would just be covering your algebraic topics. Right? In the next session, we'll cover question 2, which is going to be covering sequences and series. Right, so let us get started. So if we look at question 1, the first question, it's quite common to see in your exam papers. This will be your first question always. And here we have solve for x problems. Right? And there's a couple of techniques that we involve here. So as we can see, there's some inequalities and there's some surds that pop up. So let's just jump straight into it. So if we look at the first problem, we have 8x minus 3 in brackets, x plus 1 in brackets is equal to 3x. So let us just take a look at this and let us try this problem. So what we'll have to do here, simply, if you remember from your earlier mathematics, is that we use the FOIL method, first outers, then inners, and of course we need to follow BODMAS rules as well. Right? So if you're strong in your foundations, you'll be fine with this as long as you follow the rules. So the first thing we have to do is say 8x times x, right? And that'll just give us 8x squared. And then we go 8x times positive 1. And that will give us positive 8x. Negative 3 times x will give us negative 3x. And negative 3 times positive 1 will give us negative 3. And this is equal to 3x. Now, remember, we're solving for x. So what we want to do is we want to take this 3x and we want to move it over to the other side and ensure that all our like terms remain together. Right? So all x values stay together, all x squareds stay together, and all constants stay together. So we're going to move this over. And don't forget, when we take something over, we have to change it from positive to negative. And that's what we'll do here. So we end up with 8x squared plus 8x minus 3x. All right. And we're going to get negative 3x over here minus 3 is equal to 0. So carry on, 8x squared. This is going to give us negative 6x. 8x minus 6x is going to give us, so let's just fold it in, is going to give us positive 2x. Minus 3 is equal to 0. So the next part here is we're going to need to factorize this. Okay? And let's see. So let's just check the question paper. If they state that we need to leave anything in decimal places, that's usually a hint to tell us we're going to end up using the quadratic formula or not. So let us just take a look. Okay, so they don't, but they do for the second question. Okay. Let's take a look. So now we need to figure out our factors. So our factors of 8 are 8 and 1 and 4 and 2. And we now need to decide, okay, which of these we are going to use. So we create our brackets. Right, it's equal to 0. Oh, and as well, our factors of 3 is just 3 and 1. Okay, nothing too complicated there. 3 is a prime number. Let me go here. And we know we got to have x. And we know we're going to have 3 and 1. So this is going to be the trial and error section where we test and to see which one is going to give us the correct answer. So we go 2, 3, and 1. Let's see if we can do this. Right. And then we look at my factors. If I put, let's just try 8 and 1 first. If I put 8 here and I leave the 1 here, let's see if it works out. I know 8x times the 1 is going to give me 8x. And I know 3 times x is going to give me 3x. Now, is there any way to have 8x and 3x equal 2x? No, there isn't. Whether we minus or add, we're going to get either 5x or 11x. So no. So we can't have 8 and 1 in those positions, right? But even if I move the 3 over here, it wouldn't work because 8x times 3 gives me 24. So 8 and 1 is out of the question. So we can ignore 8 and 1. So let us try 4 and 2. So let's put the 4 here and let's put the 2 here. So 4x times 2x gives me 8x. So this 1 is still here. So we can see that. So 4x times 2x gives me 8x squared. 4x times 1 gives me 4x. And 3 times 2x gives me 6x. Okay. So now we can see we can actually get 2x from these two terms. And let's see how. So the 6 would have to be positive and the 4 would have to be negative. Right? That's what it's telling us in order to get 2x. So now we need to keep this in mind. Okay, how do we get a positive 6x? So this 3 would need to be positive. Right? And this 1 over here would have to be negative. Now let's see if it works out, if it matches up. We can just double check. Just clear this off. 4x times 2x gives us 8x squared. Right, so we'll just double check. 4x times negative 1 gives me negative 4x. Plus 3 times 2x gives me plus 6x. And plus 3 times negative 1 gives me minus 3, which equals 0. And this will give me 8x squared plus 2x minus 3 equals 0. And we can see it matches with what we got over here. Okay, so our factorization was correct. And now we just solve for x. And we just state that this term and this term will be equal to 0. So we got 4x plus 3 is equal to 0. Or 2x minus 1 is equal to 0. And now we move our constants over. So here we got 4x equals a negative 3. Remember, whenever you move a constant over, you have to change the operator sign. And then we go here, or 2x equals 1. And now we just divide by 4 on the side, and we can divide by 2 on the side. Why? Because we want the x to be by itself. We're solving for x, so we want x to be alone. So we can see that the 4's will cancel, and we'll end up with x equals negative 3 over 4, or the 2's cancel, x will equal a half. And that would be our final answer for this. Right? And we can just double check the memo. Let's see what they got. And they got the exact same values over here. Lovely. Okay. Let's go on to question 1.1.2, which is 5x squared plus 3x equals 1. And here they're telling us, solve correct to 2 decimal places. So we immediately know you're going to end up with an equation that you are unable to factorize normally. So you have to use the quadratic formula. Right. So let us just open this up. Let me go here. Copy this. Add it to a new page, and let's take a look. Okay. So first things first, I'll go 5x squared plus 3x minus 1 equals 0. Right. So we know we're unable to factorize it because in the question they asked us to round off to 2 decimal places. So we need to use the quadratic formula. And if everyone remembers, the quadratic formula is x is equal to minus b plus minus the square root of b squared minus 4ac over 2a. Now, in order to identify what is a, remember the x squared value, the coefficient there is a. For the x value, the coefficient there is b. And for the constant, this is c. But now remember to take your operators into consideration. So we can state a is equal to 5, b is equal to 3, and c is equal to negative 1. And all we do is we directly substitute this information into this formula, and we can solve for x. And so this is equal to, let me just use a different color. Let me go back here. Here we go. And this is equal to, so b is 3, so we can say negative 3 plus minus square root, b squared is 3 squared to the power of 2, minus 4, a is 5, c is negative 1. And this is all over 2 times 5. Now, let's solve this. So we're going to get negative 3 plus minus the square root, right? This is going to be 9. 5 times negative 1 is negative 5. Negative 5 times negative 4 is positive 20. Let me put that in there. All over 10. This is equal to, let me just do it over here. This is equal to negative 3 plus minus the square root of 29 over 10. Now, it's clear that they want us to use a calculator because they said 2 decimal places. I'll tell you now, when you're doing mainstream math at university, there are no calculators allowed. Right? So you would just have to leave it in surd form. So not to scare anyone out there, but that's just the reality. So x is equal to minus 3 minus square root of 29 over 10. Okay, and we can just plug this information into our calculator. And let me just see here. Negative 3 plus the square root of 29 divided by 10 gives me an answer of 0.02. And let me check the next one. Or x is equal to, let me just change that sign to a negative. All right, that's fine. And that's divided by 10. And that gives me an answer of negative 0.8385. So that means we have to round up. So I'm going to get negative 0.84. Now, those are the roots for this specific equation. And let us see if it matches up with the memo. 0.24. So somewhere either there's an error in the memo or I made an error. So let me just double check. Negative 3 plus square root of 29 divided by 10. Oh, I did make an error. I don't know how I got 0.02. It's 0.24. Okay, and once again, you have to round up because on the calculator, it gives me a value of 0.2385. Right? And that's how you would solve this problem. Very simple. Just use the quadratic equation and just be very careful with how you input your information in on the calculator. As you see, I wasn't careful enough and I made an error and got an answer of 0.02. And I would have lost the mark there because of that. Okay, let us take a look at the next problem. Let me just close that. The next problem is an inequality problem. So 1.1.3, x squared is less than 3 times x plus 6. Okay, so let us take a look at this one. Let me go back here. Just get this open board up. Let's cut out this problem. Go add it to a new page. Okay, so don't be daunted by inequalities. I know some people are quite daunted when they see these things. But if you remember how to work with number lines, you should not have an issue with inequalities at all. So in this question, they're saying x squared is less than 3 to the brackets x plus 6. Now, what we do is we just solve this in this brackets here. So we got x squared is less than 3x plus 18. Okay? We move everything over to the left. We get x squared minus 3x minus 18 is less than 0. And we ask ourselves, what are the factors of 18? Well, we can get 18 and 1, we can get 9 and 2, and we can get 6 and 3. Now we try with our brackets and we see what fits. Okay, there we go. We get x, we got x. Now I can already see I want to get 3x, so I'll ask myself, okay, so luckily we only have these factors at the end. So the x's are going to involve themselves in both of these. So we can ask ourselves, okay, if can we get, with 18 and 1, can we get 3x? No, we cannot. There's no possible way. And 9 and 2, can we get 3x? No, we cannot. But 6 and 3 seems very viable. 6 minus 3 can give us 3x, that's for sure. But we're looking at negative 3x. So we're asking for a negative 6 and a positive 3. So we can maybe input that here and say this is negative 6 and this is positive 3. And we can see if it works. X times x is x squared. X times 3 is 3x. Negative 6 times x is negative 6x. No, negative 6x plus 3 gives me negative 3x. And negative 6 times 3 gives me negative 18. So this works perfectly. Right? So now we have this information here. And we need to see where this is going to be less than 0. Right? And this is where the trick comes in. So it's not less than or equal to. It's just less than. So we need to now check on the number line. We go here. Right? We go here. We put in our values over here. Right? And we can see that at where x equals 6, we'll have it equal to 0. Okay? And where x is, we'll make this negative 3. Right? If this is negative 3, this will be 0 over here. And if this is 6, this will be 0 over here. So we can put 6 over here and 0 over here. So where would it be less than 0? So we can see, right? If we can, and we can just do this manually, if we must put information in. So let's say we take values less than negative 3. Let's take a negative 4 and we input it here. We can say negative 4 in here. This will give us negative 10. You can just imagine it over here is negative 10. Negative 4 over here plus 3 will give me negative 1. But if we multiply this together, we're going to get a value of 10, and that is greater than 0. So therefore, we can state that if we're going negative below negative 3, this is going to be positive. This entire thing over here. Okay. Now, let's try greater than negative 3. Let's try a value of negative 2. In fact, we can just try 0. It's very simple. If we put 0 in, 0 and 0, right, we got negative 6 times 3 gives us negative 18. So I know it's going to be negative over here. Now, let's try greater than 6. Let's try a value of 7. If we put 7 in here, we're going to get 7 minus 6. It's going to give us 1. 7 over here, 7 plus 3 will give us 10. That's also going to give us a value of 10. That's greater than 0. So therefore, on this side of the value, everything's going to be positive. So if we want to know where this equation will be less than 0, we can see it's going to be between negative 3 and 6. And we can just state that with a circle and a circle, right? Connecting each other. That's telling us where the inequality exists. So we can say that x has to be, we can state that over here, greater than negative 3, but less than 6. And that should be your final answer. And let us just take a look. If you go down here, x is greater than negative 3, but less than 6. Perfect. And you'll get 4 marks for that. Okay. So the next one we take a look at, give me a second, back here, is 1.1.4. And here we are involving surds. And please do not be daunted by these things. Do not be daunted when you see surds or when you see inequalities. If you just remember your rules with regards to exponents and how to work with surds, you will be fine with these. So let's take a look at 1.1.4. Let me crop this out, add to a new page. Now, let's take a look at this problem. So, the thing about surds are, if you have the square root of some value, let's just give it a variable a. This is the same as saying a to the power of a half. These are rules you should remember from your exponents, right? And now there's a pretty trick that you can use when it comes to these things, right? So if you know that it's to the power of a half, what would happen if you take something to the power of a half and you put it to the power of 2? Well, if you know your exponent laws, which is am, right, to the n, we can say that this is equal to am times n. And this over here will therefore be a is a half times 2 over 1, which is equal to a to the power of 1. And that just gives us a value of a. So what is this telling us? This is telling us that, let's say, for example, we have the square root of x is equal to 2. All we need to do is put both sides to the power of 2. So remember, the reason we put both sides to the power of 2 of the equation is so that we can maintain the same value of the equation. So we do that. Okay. And you'll see that the square root just disappears because it's x to the power of a half. Right? So it just gives us x1 is equal to 4. And we're going to use this idea to solve this problem over here. And you'll notice once we do that, we should actually end up with a trinomial, and then we'll have to factorize it. So if we go over here, now we just go square root of x minus 3. Now remember, this x minus 3 is one term, and it's completely under this 1/3. So they are not individually affected by the square root, but as one term, they are affected together. So we can just do this to the power of 2 equals 9 minus x to the power of 2. And now we solve for this. And this will just give us x minus 3 is equal to, and we obviously need to solve this, so we just write it out, right? Don't be afraid to write things out and expand them. It may help you, because sometimes what people do is they try to resolve this in their minds or in their head, and if they just had to write it down, they wouldn't have made a simple error. So let's take a look here. So we got x minus 3 is equal to 9 times 9 is 81. 9 times negative x is negative 9x. We have another negative 9x, and negative x times negative x is positive x, so that gives us positive x squared. And here we have x minus 3 is equal to 81 minus 18x plus x squared. Now, of course, I want to ensure that my x squared remains positive. So what I'll do is I'll take everything on the left and just move it over to the right-hand side. And remember, place all the like terms together. So here I'll just go x squared minus 18x. The x comes over, minus x. We have plus 81. Move the 3 over, plus 3. And that is all equal to 0. And we can go ahead and resolve the rest of this. And we just go x squared is negative 19x plus 94 is equal to 0. Now, once again, we need to find the factors of 94. That'll also help us to get to 19x. So let's think about it. What are our factors of 94? So let's just check here. If we go 94 divided by 2, that'll give us 47. So that's not going to work. Instead of 94 divided by 4, no, 94. Let's see here, divided by 6. Let me just see. 94 minus 19 is 75. So that won't work. This is a bit of a tricky one. 94. Let's see. What can we use? 30. Let's try 32 and 2. No. 35, 37 and 2. No. 27. There's quite a few options here. This is the only dilemma people will come up with when doing these kinds of problems, if you get a large number that you need to factorize, because now, of course, you have quite a few factors to work with. So I'm not going to go through all of those factors for the sake of time. Let us just check the memo see what factors they chose. If I go over here, so we got 84. Did I make an error with getting 94? Let me just check. 94. My apologies, it's 84. Why did I write 94? It's right over here. See what happens when you rush things? You make silly mistakes like that. So do not do what I do. Do not rush things. Right? This is actually 84. And this should make things a lot easier. So let's just check the memo anyway. And they used 12 and 7 as factors. 7 times 12 gives you 84. And negative 12 and negative 7 will give you negative 19x. And we'll end up finding that therefore x equals 12 or x equals 7. However, you notice something here. They're only stating that x equals 7. Why is that? Well, let's just quickly take a look over here. So we have x, which ones they use, minus 12 and minus 7 is equal to 0, right? And we ended up with x either equals 12 or x equals 7. So you have to be very careful when working with problems that have square roots, because what you need to do is you need to substitute these values back into the original equation. And we're going to see now why 12 doesn't work. So if we had to substitute 12 back into the original equation, let's take a look at this. Square root of 12 minus 3 equals 9 minus 12. So therefore, they're telling us that the square root 12 minus 3 is 9 is equal to 9 minus 12, which is negative 3. But this is not possible. The square root of 9 is not going to equal negative 3. That's the issue that we have here. Right? And that's why 12 is not fitting into the formula. Right? Actually, no, the square root of 9 can give you negative 3. It can actually give you plus or minus 3. So why are they leaving the 12 out? I mean, plus or minus 3 works. If you have minus 3 and you put it to the power of 2, it gives you 9. And if you have 3 to the power of 2, it also gives you 9. I think this might be an error on the paper because 12 does work in this equation. Is it anywhere else that it doesn't work? If I substitute, you know, it works everywhere. All right, 7 as well. Put 7 in here. Get 7 minus 3 is 4. 9 minus 7 is 2. And the square root of 4 is equal to 2. Okay. So why are they not using 12? Well, I actually don't know why they're not using 12. 12 works as well because you can square root 9 to get negative 3, but you can't square root a negative number. Right? Nor can you say negative 3 to the power of 2 equals negative 9. That won't work either. So 12 should actually be correct as well. It might be a mistake on the memo on their part. Okay, let's take a look at the next question. Let's go here. So the next question, 1.2, is where things can get a little bit hairy. Simplify without the use of a calculator. Right? And this is what we're looking at. They just want us to simplify it. 2 to the minus square root 7 over 2, bracket 2 plus square root 7 over 2, both to the power of half. Basically, they are both undersurds. They're both being square rooted. Right? So let's just copy this. Let's just go here. Let me just copy this out. Where's this? Okay, sorry. There we go. Here's the open board. Oops. And we'll just copy this, add it to a new page. Lovely. Now, so this is where your exponential laws come in, right? So if we had to imagine that this entire term within this bracket is A, and this entire term within this bracket is B, right? What we are essentially saying is that A to the power of a half times B to the power of a half. Now, this actually falls under exponential laws. And this is like saying A times B to the power of a half. It means the same thing. So obviously, if you've had enough practice with exponents, this is something that you may be able to identify immediately. And such a question can often throw people off. Okay? So sometimes it helps just to say, okay, let this term equal one thing and let this term equal another thing. And then sometimes it makes things look a lot clearer. Now, let's try that. So now basically end up with 2 to the minus square root 7 over 2 times 2 plus the square root of 7 over 2. And both of those are to the power of a half. Now, we first do our BODMAS. Let's solve everything within the brackets first. So this is going to give us 2 times 2 gives me 4. 2 times square root of 7 over 2 is just going to give me plus square root 7. Maybe I should show you why that is. I don't want to skip a step. So it's basically like saying 2 square root 7 over 2 minus 2 square root 7. Sorry, this is a 7. Square root 7 over 2. And then negative square root 7 over 2 times square root 7 over 2 is going to give us negative 7 over 4 to the power of a half. Now we can see that these two things are just opposite, so we can actually just cancel them out. And here we're going to get 4 minus 7 over 4 to the power of a half. Now, we solve within the brackets, basic fraction manipulation. 4 times 4 is 16. 16 minus 7 is 9. So this is going to be 9 over 4. So we got 9 over 4 to the power of a half. Now, remember I told you that this is the same as saying square root. So we can just say that this is the square root of 9 over 4. And our answer will be 3 over 2. But because it's a square root, it could be plus or minus 3 over 2. And let's just check the memo. What do they say? And there we go. 3 over 2. Easy peasy lemon squeeze. Not too hard. Right? It's just this part that might throw you a little bit off. Now, let's take a look at the next problem. Solve simultaneously for x and y. Now, this looks a little bit hairy. I can understand why. We see we have the summation formula over here. This often throws students off. Okay, so let's try to understand summation formula first. This will be easier. If we know that we may need to solve simultaneous equations, we need equation 1, equation 2, and there's quite a bit of substitution that happens. So let's just jump into it. Okay, yeah. Let me cut this out. Add to new page. Okay. Now, if we take a look at this problem, let's first try to understand summation form. So this k equals 3 value. What this is telling you is that this is the starting value that we need to use. Okay. And then this 4 is the ending value that you're going to use. So they're telling us that we're going to start with 3 and we're going to add to the value of 4, where k is equal to 4. So we're starting at k is equal to 3 and we're ending at where k is equal to 4. This is ending value. Okay. And this sigma over here, this is what this is. This is sigma. That's also called sigma notation. This is just telling us that this is the sum of whatever is going on here. And they're telling us that this, whatever the sum of this is going to equal to 5y. So let us take a look. Now all we do is step 1. We first use k equals 3. So we can write 3. So wherever you see k, you can replace it with 3. So we got x bracket 3 minus 2 to the power of 2. Now because it's summation, we say add. And we do this again, but now we go to the next value. So if this was, say, going to 5, the next value would be 4, and then the next value would be 5. If it was going to 6, 4, 5, 6, and so on and so on. We just repeat the process, and we keep adding with the new k value. So here we just go x bracket, k is equal to 4. So we just state the 4 minus 2 to the power of 2. And this is supposed to equal 5y. Now let's go ahead and solve it. So we know 3 minus 2 is 1, and 1 to the power of 2 is 1. So 1 times x is x. I can just write x over here. Plus 4 minus 2 is 2. 2 to the power of 2 is 4. 4 times x is 4x. And this is equal to 5y. So now we end up with 5x is equal to 5y. Therefore, we can say that x is equal to y. And we can call this equation 1. This over here is equation 2. So what do we do? Well, I'll call this equation 2. I'll just write 2 here. Right? And then we can just say substitute 1 into 2. And that's what we'll do. Wherever we see x, we replace it with a y. Okay? Now, we do this. So x, we do this here. So we're going to get 6y equals 9 minus 18y plus 16y squared. Now, we just rearrange the formula. And we're going to get 16y squared minus 18y. 6 comes over, minus 6y plus 9 is equal to 0. And let's just go bring it up over here. And now we try to resolve this problem. And we can just go, well, then 16y squared is minus 24y plus 9 is equal to 0. And now, of course, we need to factorize this. Let's see, is there any way to simplify it further? 3 goes into 9, 3 doesn't go into 2, it goes into 24. Does 3 go into 16? No, it does not. So we cannot take out a common factor of 3 to assist us in simplifying it. So we have to factorize as is. We go here, brackets, 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 equals to 0, y and y. And here comes the fun part, trying to figure out what factors we need to use. So we know for 9, we have, if we look at 9, we will have 9 and we will have 1 and we can have 3 and 3, right? For our 16, we can have, well, we can have 8 and 2, and we can also have 16 and 1, but we can also have 4 and 4. Right? Now, we need to determine which one is going to be the best to use. So this is basically comes down to trial and error. You substitute in and you see what works. So let's take a look and see if we can do that. So if we use 8 and 2, let's put 8 over here. We put 2 over here. Right? We need to get to negative 24. Now, if I use 3 and 3, let's just see. I'll just put this in here, 3 and 3. 8y times 3 is going to give me 24y already. So there's already a problem. We already made 24y. So we can't use 8 and 2 and 3 and 3. It's not going to work. What we can use, and I see it now, is we can use, let me just shrink the size of that. We can actually use, if you look over here, we can use 4y and 4y. Now we can see it's negative and negative, so it has to be negative and negative. And let's see if it works. 4y times 3 gives me 12y, negative 12y. Negative 3 times 4y gives me another negative 12y, and that'll give me negative 24y. So here, our answer is going to be, well, therefore, 4y minus 3 is equal to 0. Therefore, y is going to equal 3 over 4. But since x is equal to y, according to equation 1, we can also say, therefore, x is also equal to 3 over 4. Right? Because if you substitute this back into here, you will see you'll get that same value. And let's see if we are correct for 1.3. And there we go. Y is equal to 3 over 4, and x is equal to 3 over 4. Okay, then let's take a look at another question. We have about 6 minutes left. So let us just take a look at another problem. Let me go to a different paper. Let's go here. Okay. So let's take a look at something interesting. Let's take a look at 1.3. Right? Sometimes these kinds of problems can throw students off. So let's go to 1.3. Let me just go here. Add to new page. So for 1.3, they state if the function of x is equal to the square root of 27x cubed and g of x is equal to x to the power of 6, determine f bracket g bracket 4. So we've got a function within a function. So what you do is you always first solve the inner function, get that value, then you replace the value with what g to the power of g bracket 4 is, and that'll help you solve for f of x. So let's first see what this is. So we got g of x is equal to x to the power of 6. Now, the 4, we can just go g bracket 4 is equal to 4 to the power of 6. And what is this value supposed to be? Well, let us just check on the calculator. Let's remove that. 4 to the power of 6 is 4,096. Now, we can put that in here, 4,096, right? But now let's see. I don't think we need to use 4,096 in the calculation, but let's see what happens. So we can now go, well, if that's the case, then that must mean that fg bracket 4 is actually equal to 4 to the power of 6. Okay, now let's resolve this. So therefore, that means that if wherever we see whatever our x value is, this is what it's going to be, 4 to the power of 6. So therefore, f 4 to the power of 6 is equal to the cube root. Right, we can put this in brackets, 4 to the power of 6. Now, once again, this is where your exponential laws comes in, and your laws regarding surds also come in. If you have a times b within the same surd, you can actually write it as the square root of a times the square root of b. Means the same thing, right? So, and we can test this, and I'll show you it's true. So if we go the square root of 4 times 4, right? We know this is the square root of 16, and that's going to actually give us an answer of 4, right? We know this. So, but let's take a look at what happens. Square root of 4 times square root of 4 is equal to 2 times 2, which guess what? Equals 4. So therefore, the statement is true. This works, right? So we can actually do this. So let us take a look. So let's try that over here. So we can also do that with a cube root. Do not be concerned by this value over here. You can still do it, right? So we're going to go the cube root of 27 times the cube root of 4 to the power of 6. Okay. Now, the cube root of 27, if I remember correctly, that should be 3. 3 times 3 is 9. 9 times 3 is 27. That is correct. So this is going to be 3, right, times by, and if we look at this, this can be quite scary. But remember, I told you that the square root of something is just a to the power of a half. So what is the cube root of something? That is just a to the power of a third. That's all it means. So we are just multiplying this exponent 6 by a third. So this is like saying 4 to the power of 6 times 1 over 3. And this is going to equal 3 times 4 to the power of 2. And we get up with the answer of 3 times 16. And this is going to equal, let's check, 16 times 3 is 48. That should be our final answer. Let's see if we are correct. Is this the correct memo? And there we go. Our answer is 48. And there they showed the alternate solution. Or we could have just substituted this straight in. Right? And there we go. So that is it for question 1 with regards to paper 1. That would have been with regards to algebra. And then our next session, when we commence, we will be looking at question 2, which is sequences and series. And there's quite a bit of detail involved here with regards to the different types of equations that you may need to use. You'll need to be able to identify between a quadratic sequence, an arithmetic sequence, and a geometric sequence. You also need to be able to identify when to use the summation formulas for different sequences and series as well. And we will take a look at that, and we'll go through the nitty-gritty of the details with regards to what a term is, and what all those small pieces of information mean, right? But all the small pieces of information come together to help you solve and see the bigger answer of things. So we will end there for today. We'll conclude the session, and I will see you all again on Monday.
Shukran so much, Muntasir. We really, really appreciate that. Thank you so much for taking the time out of your day to us in this Matric Revision Program. We really, really appreciate it. Shukran so much.
Afwan, very much. Thank you for having me and allowing me this opportunity to, share the knowledge with the students, and hopefully it'll help them push through their grades and do well at school, and
Inshallah,
get
I
to
mean,
do what they
hopefully
want
it
to do.
is true. Yes, hopefully they can do better than I. I only got 50%, so so hopefully, alhamdulillah, if I had your assistance, maybe I would have gotten a little more.
You want to know something? In high school,
Yes.
I also only got 50% for math, and at
Wow.
university, I got 78%. So there was a flip
Jeez.
somewhere. There was a change somewhere.
I should have found that change from 50 to 78 in university. Wow, that's a massive improvement. But anyway, we have to end it off there. Shukran so much for coming on board. Have a fantastic day forward. Assalamu alaikum.
Wa alaikum salam wa rahmatullahi wa barakatuh. Thank you for having me so much.
No problem.
you.
And to
Enjoy
all of our
the rest of
wonderful, no problem. You too. To all of our wonderful listeners, shukran so much for tuning in. You can catch this if you miss anything. It will always be on our YouTube page or our Facebook page. So you can catch it there. But from my side, Daanyaal Matthews, Voice of the Cape, I bid you adieu. Assalamu alaikum wa rahmatullahi wa barakatuh. That's it for the Matric Revision today. Tune in tomorrow at the same time, and there'll be more.